Okay, Assalamualaikum and good evening. I'm going to start our online class tonight. We'll be on topic 4. There are a few subtopics in this topic 4. And for your information also, I'm going to share later on the changes on the topic for remaining weeks. So if you remember, last 2 weeks we had our what we call it disaster leave and then festive leave. So I think that I'm going to start with week 10, even though we are currently in a week 11. So I hope that there will be no problems to every one of you to catch up and to have what we're going to learn later on. So without further ado, let me share my slides for this topic 4. So this will be on the, what we call it here is a pile. So I hope that every one of you can see my slide, and for, for the time being, I will having a sessions that need to admit every students that join later. Okay, these are the contents that will be covered for carrying capacity of piles and pile group. So this is the what we call it the big topic or the big title of the topic, and then we split into few subtopics here. For example, design and analysis of deep foundations. We focus on the first one is the single piles. Um, and single pile supposedly, and then we're going to understand and learn the concept of frictions and bearing piles, bearing capacity analysis of pile using empirical and theoretical formula. For your information also, there are differences between empirical and theoretical formulas. For example, here, later on you will see that how the concept of bearing capacity for the file is deriving from the concept produced or proposed by uh, past researchers such as Terzaghi, Meyerhoff, Benson, etc. And then in comparison to empirical formula is something that you come out with the mathematical expressions that you may see from your observation or from field or site experience that you have on the soil testing, for example, and you are doing the analysis and then you come up with some sort of the empirical formula or empirical equations. So what you may learn from this subtopic is explain the end bearing and skin friction contribution to pile capacity, estimate the bearing capacity of a pile from empirical and analytical formulas. So this is what I said or what I explained just now is something that we're going to have some kinds of pile types and category and bearing frictional pile. So wait a second, I think that someone is trying to join this class. Okay, so let us move on to the next slide. Okay, what is exactly is the pile and what is the difference between pile or commonly known or called as a deep foundations compared to the shallow foundations? So I think that Dr. Nurul has covered for the what we call here is a shallow foundations, if I'm not mistaken. So if you look at from the structure or from the embankment depth, you may see that the limiting depth for the shallow foundation is maximum to 3 meter. If you encounter soft soil and very difficult or very problematic soil, which need to carry high loads and need to find the hard layer of the soil, which more than 3 meter, during this time you need to have another options of the foundations that we call it here as a deep foundations. So in purpose of the applications of deep foundations, for example, if you construct high-rise building or the application will be built on the soft soil, or if you have some kinds of granular soil that may have a low resistance, so that is the time when you need to consider the deep foundations in terms of the cost as well. So in back to the definitions or the functions, you may see that it is purposely to transmit foundation loads through soil strata of a low bearing capacity to the deeper soil or rock strata having high bearing capacity, or using the normal ground conditions to resist heavy uplift forces or in poor soil conditions to resist horizontal loads. So this is a very common things that whatever foundation sama ada shallow ataupun deep, the purpose is to transmit, and then we want to have some structure yang boleh carry beban daripada superstructure dan meet to the hard layer ataupun high bearing capacity. But then when you look at the current situations last 2 weeks, when we encountered with the flood disaster, for high-rise building, for example, you may see that erosion occurred near to the constructed area ataupun dekat kawasan bangunan yang dah dibina. So you may think how to what we call it here to remedy, to repair some kind of the structural failure as well as the soil failure. And then back to that one, you may see that the pile is not working anymore to sustain the load from the superstructure. Okay, what are the factors affecting the pile selections? Yang ni saya tak akan explain banyak lah because we have many slides for tonight. So I just cover or go through some the headlines, for example, in order to select the best pile selections or the pile type, you need to consider few factors, for example, location and the type of the structure. For example, if you are construct for bridge, so that what will be the best material of the pile, and then what kinds of loading that you may cater to carry the loads, and also the location. Is it you going to construct a building or any applications in the oceans or near to the hill slope? So these are the things that you need to know. What is the pile selection, pile type, and then what is the best method of the pile installations. Okay, other than that is the ground conditions. It is very common if you remember in the early semester you register this course, Dr. Nurul has explained to you the first topic on the site investigations, how it is important the site investigation to the geotechnical engineer to understand the ground conditions before you can further to the what we call it to the design and constructions of the process. Without knowing of these soil properties or ground conditions, there will be future consequences that you may face, for example, failure. So I think that this is a very good when you take this course and then you try to what we call it, try untuk guna balik lah kan apa ilmu dengan you punya experience, working experience in a way to provide better facility or better infrastructure to the public needs. Okay, and then the next one is durability. So this one is kalau kita buat constructions ataupun pile tu dekat kawasan marine conditions, and then this one it may says that the precast concrete may be preferred to steel piles from the aspect of resistance. So ada beberapa kriteria lah bila kita nak pilih pile kan. If you want to use timber pile, what are the consequences ataupun what are the strength, the durability of the material, is it can cater the load ataupun load ni it can be vertical, it can be horizontal ataupun dia boleh jadi dalam bentuk what we call it inclined loads kan. So benda-benda ni yang kita kena pertimbangkan lah kan. Selain daripada tu adalah faktor cost. Cost ni kalau you as a contractor, you may concern about the cost and then project durations. You may see that if you have a wrong decision, for example, that may delay your project as well as your cost. So bila project tu tertangguh, dia akan consume time because we know that the cost material dia bukan dalam keadaan stagnant. It will be rising by time and time. So even though kita having the crisis, economic crisis, the material keep rising, keep increase the cost. So in this case, we have to proper plan and design for better options in a way to select the pile type. And other than that, I think that these are the same thing. So these are the main categories for the classifications of the pile. For example, we can classify according to material type, and then we can classify under the soil effect and the functions of the file itself. For example, kalau kata just now I explain there are few factors, kita akan tengoklah kalau pile jenis timber sesuai tak dekat kawasan berair ataupun steel pile, is it suitable to be constructed in the marine area. Ini contoh-contoh lah yang kita boleh kategorikan our pile classified. And then we look at to the soil effect. Bila kita ada driven pile, kemudian kita ada bore pile, they will be talking about the pile installation and also pile operation and construction. So kita akan tengoklah adakah bila kita buat driven pile, of course you akan ada some kinds of the vertical displacement. Kalau kita buat bore pile, we have to replace ataupun kita kena correct certain amount of soil, we remove, kemudian kita letak jaring-jaring besi sebelum kita pour concrete inside the hole. So that is the differences between that's are different differences between the bore pile and also the driven pile. And the type number 3 is I think that is very common lah when we talk about pile, kita nak tengok the capacity, the end bearing capacity, and then kita nak tengok the skin frictions of the pile itself. And kalau kata talking about skin frictions is the shaft resistant. Kalau untuk clay tu macam mana? Kalau untuk sand tu macam mana? And bearing pile ni of course kita akan tengok pada tapak pile tersebut. So berapa dia punya keupayaan galasan. So at this time you need to know how to calculate the effective overburden pressure, and then you need to know what is the bearing capacity factor, and then you need to know what is what the cohesions of the soil, the internal frictions angle. So dia akan ada some empirical formula lah untuk dia correlate antara one parameter of the soil dengan parameter yang lain untuk having the kind of formula and get the bearing capacity of the soil. Okay, these are the pile type. For example, timber, composite, and then raised shaft, cast in place concrete piles, micro piles. So in Malaysia, I think that commonly we use the span piles and then micro piles lah. I'm not sure lah kalau kata on sites you having a different options or solutions for this kind, because every solutions or every option that you choose in your repairing work ataupun any new project, they will be involved dengan cost. So kalau kata project tu lah heavy project kan, heavy cost, so you need to have the best pile, then you kena bear the consequences lah, cost dia tinggi. Ini contoh antara kategori classified pile jenis pertama iaitu material. So kita classifykan mengikut jenis dia lah. For example, concrete, timber dan juga composite. Composite is a mix antara two different materials. For example here, kita mungkin ada steel and then we may have also concrete on top of it. Okay, if you classify according to the soil effect, for example displacement, ini antara dia punya kategori lah. So displacement kita akan tengok pada large displacement ataupun small displacement. And then if you look at to the bore pile, so bore pile ni kita akan mostly dia talking about the installations and the construction process of the pile. So kalau bore pile ni is some kind classified bawah dia unsupported during construction ataupun dia supported during construction. So you can see lah dia punya kategori dia. For example here, steel casing, kemudian ada drilling mud, and then you can fill dengan concrete kan, for example lah. Okay, this is type 3. Kalau kita classify according to the functions, we have the bearing capacity, we have frictions, and then you have the combined functions ataupun combined piles. Same goes to here but different application. For example here racking pile, kemudian kalau you ada retaining wall supported by having a vertical pile ataupun better pile, and these are depending to the loads yang dia carry. Semua ada only vertical ataupun axial compressions atau it also has lateral loads. Okay, if you classify according to the soil effect, for example, the driven pile, so the piles are driven or pushed, vibrated or screwed into the ground, displacing the soil outwards and downward, but no materials are removed. So this is the major differences lah. Satu tu tanah dia remain inside there, satu lagi kita akan remove, kemudian kita gantikan dengan steel casing, and then we pour dengan concrete. So somehow it can be reinforced dengan ada admixture lah untuk kita strengthen the pile functions. Okay, for displacement piles, the materials that perform this categories. For example, here is the timber, concrete dan juga steel. So you need to look at the advantages and disadvantages if you are using this pile into this type of constructions ataupun soil effect, for example driven or the bore pile. So I think that you can read from here. So the important part when you talk about pile is on the embedment depth, the length of the pile, the diameter of the pile, and then the working load, the design loads. So itu antara parameter-parameter yang kita kena lihat lah. Selain daripada tu, kita tengok compressive concrete strength, FCU, kemudian we look at to the shear bending. So in this part, dia adalah combination between the structural and geotechnical applications lah. Okay, another example is a timber piles. So yang ni you can have a square dimensions, for example 225 by 225 millimeter, or you may also have a 600 by 600 millimeter. So it's easy to handle and driven by percussions or drop hammer. And then kalau you look at to the timber piles kan, some timber piles ni untuk kita elakkan dekat bahagian bawah dia tu pecah, kita akan letak some iron lah, ataupun dalam constructions tu bila dia melibatkan water table ke apa, in order to secure the timber structure itself tu, kita akan letak some combinations on top of it is a concrete pile, dekat bahagian bawah tu adalah wood pile. Okay, ni pun sama. So yang ni pun I leave it to you lah. Because concrete piles ni is another way untuk driven effect lah. Kalau you nak choose to this method, available contoh-contoh lah yang ada dekat market. For example, precast reinforced concrete, precast pretension span concrete piles. So bila look at to these categories is actually depending to the strength of the pile, berapa dia punya kekuatan boleh menanggung beban ataupun loads yang ditindakkan ke atas structure pile tersebut. Okay, I think that this is a very common on the slope reinforcement repairing work. So ada yang menggunakan timber or span concrete piles untuk large in specific construction site, atau ada yang menggunakan micropile for slope repairing work. Okay, same here. Okay, kalau steel pile kita ada pelbagai kategori lah. For example, H section, and then we have the box piles, and ada yang jenis driven and cast in place pile. So talking about the displacement ni, you can see that displacement pile formed by driving a tube with a close and either with a plug or loose screw into the soil to required depth of set. Reinforcement and concrete is filled in the tube. So this tube may or may not be withdrawn. So the suitable where the length of pile required varies, bergantung kepada loading lah. Economically formed in diameter of 300 to 600 millimeter, which can carry up loads up to 1,600 kilonewton. So that's why I said in a way to select the pile material tu or any functions, you kena tengok lah dia punya manufacturing design capacity loads tu berapa yang dia boleh cater. Okay, other problems, whatever piles that you choose, dia akan ada advantage and disadvantages lah, ataupun dia ada some kinds of problem that you may face, for example necking and then ground heave. Ground heave ni most often occur encounter in the soft soil, clay for example. So can cause tension failure in the shaft of adjacent piles already driven, and in worst case lifting of the completed piles. So however, this can be minimized by the enlarged base of the piles in conjunction with the reinforcement in the shaft, thus anchoring the piles against the uplift. So it has a problem, it also has a solutions. So we need to tackle how to solve the problem. Okay, ini adalah some kinds of the example driven and cast in place pile. Okay, box. Okay, now we go to the bore and cast in place pile. Yang ni adalah jenis pile yang mana kita akan remove soil, kemudian kita akan letaklah steel reinforcement, and lastly kita akan pour concrete. So kat mana dia sesuai pakai? Just as well to use in sites where piling work to be carried out close proximity to existing building or where vibration or noise restricted. So it is very orang kata apa, important key to highlight the applications of the ball and cast in place piles. Okay, antara contoh-contoh yang kita panggil lah bila you buat bila you buat ball pile, dia mesti ada this kind of the accessory lah, kita panggil accessory, for example ya, percussion board ataupun battery board. Okay, antara advantage dia adalah length can be readily varied to suit varying ground conditions. So removal in boring can be inspection, and if necessary sample or in situ test made, can be installed in very large diameter, and enlargement up to 2 or 3 diameters are possible in clay, can be installed in very long length, can be installed without applicable noise or vibrations, can be installed in conditions of very low headroom. So no risk of ground heave. So kita boleh tackle lah isu ground heave tu dengan pakai bore and in cast place. So apa disadvantage dia? Okay, contohnya concrete is not places under ideal condition and cannot be subsequently inspection. Itu antara kelemahan dia lah. So kita tak boleh nak buat inspections. Water under artificial pressure may pipe up pile shaft washing out cement, enlarge and cannot be formed in cohesionless material, cannot be readily extended above ground level, especially in river and marine structure. Boring method may loosen sandy and gravelly soils. Sinking piles may cause loss of ground in cohesionless soil, leading to settlement of adjacent structure. So kalau you look at here, when you construct pile or in chapter shallow foundations pun settlement you akan cover juga. So whenever it is apa-apa kerja yang melibatkan compressions ataupun you push something into soil, we need to consider the effect of displacement. But this time because pile is moving downward, so kita akan tengok vertical displacement lah. Okay, yang ni adalah contoh kalau you menggunakan percussion bore pile. So it's very suitable for clay or gravel subsoil. So dia ada limitations lah, diameter dan juga design load berapa. And also if you have a steel tube, 1 to 1.4 meters cultivated in some by extracting the soil from within the tube liner using percussion cutters. So on part of here, this actually is a pile installations process lah. So it's easy by having or you have some time to watch from the YouTube how it works on sites operations lah, untuk lebih jelas bagaimana percussion bore pile is constructed ataupun is work on site. So ini adalah gambaran dia lah, the process from the beginning 1 to 8 lah. I think that I'm not here to explain. I'll leave it for you to read by yourself. Same goes to the auger bore pile. And this another one, same here. And also the process involved from 1 to the last step is 14. Okay, rotary drilling wheel with Kelly. And same last year. Okay, composite piles. So the composite piles is combinations or 2 or more types as mentioned, or combinations of different materials in the same types of pile used in ground conditions where conventional piles are unsuitable or uneconomical. For example, just now I mentioned kalau kata kita nak pakai timber pile dekat kawasan sungai ataupun kawasan laut kan. So kita akan pakai combined pile. So I have 5 minutes off. Wait a second, eh? Okay, I'm back. So let us continue. Okay, composite pile. So advantage, problem of necking is eliminated, which made it suitable to use in waterlogged soil. So construction stage, there are four. I think that start dengan borehole formed by percussion board method. Precast units which form the core of the pile are assembled on a special mandrel and reinforcement is inserted before the core unit is lowered into positions by means of pneumatic winch. Withdraw the lining tube and routing with the aid of compressed air to expel any ground water. So ini antara contoh, saya sambung Okay, ini antara contoh lain iaitu composite pile. So it's a driven or displacement pile consisting of series of precast shells treated on the mandrel and top driven to the required set. After driving and removing the mandrel, the whole core can be inspected, cage of reinforced can be inserted and void filled with in situ concrete. So how did this the face or the shell composite pile? It is please take your time to see on this kind of composite pile. Sebab kalau tengok tadi macam mana combinations untuk composite pile, for example kita ada concrete, kita ada steel so you can see that kat mana yang akan duduk at the lower part, which material yang akan berada pada upper part. So somehow bila you look at to the timber construction pile dekat kawasan air ke apa, so the pile cap will be constructed dekat kawasan, selalunya kita nampak pile cap tu on the ground surface kan, but this time bila timber you construct dekat kawasan berair tu, so you akan nampak pile cap tu dia akan go lower in the lower daripada ground surface. Okay, ini antara advantages and disadvantages untuk shell composite pile. So this another different of composite piles. So ini dia punya pile shoe. Ada different faces from A, B, C and D. And for the special types of pile kat sini dia bergantung kepada applications lah. And also the type of load. For example, kalau kata the pile used to resist uplift load, so yang tu kita akan ada this kind of, we call it as a tension piles. So it is also known as a uplift piles or anchor piles, a type of pile foundation that is used to resist uplift forces that might otherwise cause it to be extracted from the ground. So uplift forces can be developed as a result of hydrostatic pressure, seismic activity or overturning moment. So ini antara yang behavior lah you akan nampak bila you menggunakan uplift piles. And what is the function ataupun kenapa kita menggunakan uplift piles ataupun tension piles is to resist overturning in the tall buildings. So the next one is a racking pile. It's a pile that is not driven vertically or some kinds nama lain is a better pile. The applications near in the harbour and the river installations. So you akan nampak lah the pile itself embed inclined directions, not in the common kita nampak di dalam keadaan vertically. Okay, same thing here yang tadi untuk tension piles, but you can see for example here the skin frictional resistance is much lower than those for compressions, so 50% reduction is suggested. The pull-out test may be conducted for this kind of the tension piles, and the lateral force, for example wave action, if transmitted to pipe will destroy most of the skin frictions. So the applied factor of safety to design the tension pile is a 2, and there is no end bearing resistance. So it is to be designed for both compressions and tension loads. So yang ni yang bagus about the tension pile. So they can cater for the compressions and the tensions load. Okay, the next one we go to the the last of these special type of pile is the shear piles. So the shear pile consists of cantilevered reinforced concrete drill shaft designed to resist shear and bending moments demand resulting from loading by the landslide. So the 3 shear piles were instrumented with inclinometer casings attached to the rebar cage. So it is resist to horizontal forces and the movement. So kalau nampak I have given 3 special types of piles yang dia tak sama macam yang saya sebut tadi lah. Ada pile yang end bearing and then skin frictions capacity, ada combine ataupun dia berbeza dari segi material, or this one is berbeza dari segi applications dan juga dia punya fungsi in terms of the stability. Okay, now we go to the theoretical part in a way to understand what is the friction pile, kemudian end bearing pile dan juga combined pile. So as you can see from here, these are the interface forces between the structure and also the soil. Kemudian you akan nampak also there is one upward forces at the bottom of the pile, and we have the working load that acting compressions axially to the pile that we construct. In order to understand the definitions or differences between the end, or some will call it as a point bearing pile, then juga friction pile, you can see that in this in kita panggil gambar kartun lah, macam mana dia nak cerita pasal end bearing pile. End bearing pile ni dia akan measure at the bottom of the pile dekat kawasan hard layer. So macam mana kita nak tahu hard layer ni? Kita kena, kalau kita ada in situ testing tu, kita boleh tengok pada SPT end value lah. Kemudian kalau talking about the friction pile, so it is addition or the shaft resistance along the perimeter pile, sekeliling sekitar dekat bahagian pile tersebut. So if you have the combined pile, so kita akan look at in both lah, in terms of the deriving formula, dia akan ada antara point bearing pile dan juga friction pile. Okay, for the friction pile in cohesionless soil, for example, the applied load is transferred to surrounding soil mainly through skin frictions along the surface of the piles. So cohesion, dia punya strength dekat bahagian skin frictions lah. A large part of load is also carried by the pile too. So the skin frictions resistance varies mainly with the relative density of the soil and with the shape of the pile. Okay, dia as I said lah, the durability and the strength or the material, the stiffness material of the pile. Kemudian kalau you ada different kinds of friction piles in cohesive soil, so it is almost the whole load on the pile is transferred to the surrounding soil along the pile surface through the skin friction, and only a very small part through the pile too. So untuk friction piles in cohesive soil, kita akan look at to the cohesion strength parameters in terms of the frictions or the skin resistance. For end bearing piles, the pile driven down to a layer with a high bearing capacity, so the applied load is transferred from the pile to the surrounding soil mainly through the pile too. So this is one of the complete explanations on the ultimate bearing capacity of the pile at the static conditions. So kita tak ada dynamic effect lah ataupun dynamic load. For example here, if you have a axial load that acting to the cross-sectional area of the pile, kemudian kita ada embedded length D, and then we also have the ultimate or end bearing capacity at the two pile QP as a QP AP, and then along the shaft kita akan ada skin bearing capacity, so which is F darab dengan AS. What is the F? F is the unit frictional resistance, AS is the shaft area, QP is the unit bearing capacity, AP is the area of point. So the area of the point is depending on the type or the size of the pile. For example, kalau kata you are using the square pile, the square steel pile, so area of the point ni kita akan ambil B darab H lah, for example. Lebar darab dengan dia punya panjang. Kalau kata you are having the circular pile, kita akan ambil area pi d square over 4. For the area shaft, AS, yang ni pun sama juga, dia bergantung kepada pile size lah. Kalau kata kita ada square pile, kemudian kita ada circular pile, so formula dia akan berbeza. So kita akan tengok kepada perimeter, luas perimeter pile tersebut. So kalau kata kita ada square pile, so we have to consider the area times dengan berapa. Sorry, kalau contoh kita ada circular pile, kita nak dapatkan AS dia, kita boleh calculate dengan pi dl. So that is the perimeter shaft of the pile. So same, this will be different kalau you ada square pile. So yang tu kita kena reflect baliklah kepada the size and also the dimensions of the pile. Easily to say lah. So sebenarnya kalau you look at to here lah, QP dan F ni adalah satu formula yang dalam dia ada lagi beberapa what we call it, some kinds of the interactions ataupun relations dengan parameter yang lain. So similar here. Before that, this is how it is deriving to explain the load transfer for different theoretical from different researchers. For example, A, how it is derived according to the Terzaghi formula, and then you can see that the transfer of load distributions along the pile from the Meyerhof itself, you akan nampak dia distribute dalam bentuk, kita panggil dalam bentuk berbawang lah. Kalau kata researchers yang lain will give different how it is evolved from one researchers to other researchers in a way to explain how the load transferred in the pile. Okay, yang ni sama juga saya dah bagi tahu apa fungsi pile untuk carry dan transfer load structure kepada kawasan ataupun hard layer of the soil. So kita ada beberapa komponen penting foundation. For example, we have the pile cap and the piles. Piles ni is a long and slender members which transfer the load to the deeper soil or rock of high bearing capacity, avoiding shallow soil of low bearing capacity. So yang ni fungsi dia lah macam saya cakap tadi. Kalau kedalaman dia lebih daripada 3 meter, so you dah tahu dah memang tak sesuai lah pakai shallow foundation. So you akan pergi kepada deep foundation. And then you look at to the ground conditions pula, memang ground conditions tu tak suitable support the shallow foundation. So we go to the deep foundation, for example pile. So the main type of material used for piles are wood, steel and concrete. So yang ni pun sama balik, just refresh. So the function is the same on highlighted, unstable and weak soil, which we can estimate the settlement, and also for purpose of cost estimations, if you make comparison antara shallow dengan deep foundations, kemudian kalau kata you ada deep foundations untuk different classification on different material, so mana yang lebih economical cost, itu yang akan jadi dia punya solutions. Other than that, it also depends on the applications lah. Kalau kata you nak construct area yang dekat kawasan offshore ke, so you kena consider lah maybe the tension, the special piles, for example uplift force pile yang lebih sesuai ataupun racking pile yang lebih sesuai digunakan berbanding pile yang lain. Okay, we go to the explanations ni. What is the end bearing piles? The end bearing piles is the piles transfer their load onto a firm stratum located at a considerable depth below the base of the structure, and they derive most of the carrying capacity from the penetration resistance of the soil at the toe of the pile. So we look at this bottom lah, dia punya end bearing. And then if you look at here, the pile will penetrate until mid to the hard layer. Sama ada hard rock ke ataupun hard stratum clay, hard stratum sand. So that's the indicator yang mana pile penetration tu dia dah stop. Okay, untuk friction piles ni is a piles also transfer their load to the ground through skin frictions. The process of driving such pile does not compact the soil applicably, so this type of pile foundations are commonly known as floating pile foundations. So ini kalau dia stand alone as a friction piles. Yang just now tadi is stand alone for end bearing piles sahaja. But somehow kita menggunakan both, iaitu friction piles dan juga end bearing pile. Mostly when you design, we consider or we design the ultimate bearing capacity of the pile having the effect from end bearing and also the skin frictions. Okay, dalam skin frictions ni, just now it mentions on the, is also known as floating pile foundations. So the piles of the category are sometimes called compaction pile. So during the process of driving the pile to the ground, the soil becomes molded and as a result loses some of its strength. So therefore, the pi is not able to transfer the exact amount of load which is intended to the immediately after it has been driven. So usually the soil regains some of its strength 3 or 5 months after it has been driven. So agak lambat lah untuk dia reach to dia punya strength. Another one is that bila kita buat kita penetrate, dia akan ada some inverse resistance, iaitu kita panggil sebagai negative skin frictions. So the negative skin frictions is the value of the shaft resistance developed between the pile and soil in a downward direction and results in the increase of the load on the pile. So it develops when piles are driven through a layer of fill material which slowly compacts or consolidates due to its own weight. So the layers underlying the file consolidates under the weight of the fill. So yang ni adalah this kinds to explain the having some sort of the negative skin frictions. So kita ada contohnya kita ada satu layer fill, kemudian kita ada soft layer, and at the bottom part here we have a hard layer. So you may see that the difference in the directions of the skin frictions. So in terms of the formula, you may see that here the allowable capacity of the part is something that total ultimate bearing capacity over factor of safety minus with the Q and F, negative frictions. Okay, this is for combination between the friction pipes and cohesions. So what is the good things about is this pipe is an extension of the end bearing pipe when the bearing stratum is not hard, such as firm clay. The pipe is driven far enough into the lower material for the variations. So this is achieved by forcing a pulp of concrete into the soft stratum immediately above the firm layer to give an enlarged base. So a similar effect is produced with bore pipe by forming a large cone or bell at the bottom with a special reaming tool. Bore pipe which are provided with a bell have a high tensile strength and can be used as a tension pipes. So bore pipe is actually having different categories lah. Kalau you look at to this one, this kind of bore pipe is having some another sections at the bottom part here we call as a bell shape. So bila you ada bore pipe yang ada bell shape ni, dia produce high tensile strength. So yang ni kita akan cover in the next week if I'm not mistaken for the bore pipe categories. Okay, this is exactly loads applied to piles. So as I mentioned, we have vertical load, kemudian kita ada horizontal load, we also have a moment, and also forces ni ataupun moment ni dia akan bertindak pada mana applications ataupun pile constructed. So the analysis of piles subjected to lateral and moment loading is more complex than simple vertical loading because of the soil structure interactions. So it is true, kalau you ada case combined loads, it's more difficult, meaning that if you want to analyze by hand calculations, for example, it may take longer time. Same goes when you are using the computer software, there are forces and then moment yang you kena consider selain daripada effect of the soil structure interactions. So dia akan ada satu parameter lah untuk kita hubungkan antara soil dan juga structure interactions on the analysis kat sini. Bila you menggunakan computer software lah. So we need to determine the parameter before we can further analyze it. Okay, for the static approach for pile analysis, again, this is example kalau kata we have a ultimate bearing capacity of the pile, QU, kemudian we need to calculate the bearing capacity that consists of the end bearing resistance and also the shaft resistance, ignoring the weight of the pile. So this is the formula, QU, QB plus dengan QS. Just now, you may see that I may use the symbol QP. So the same thing, dia boleh panggil sebagai point bearing load ataupun ultimate point bearing resistance ataupun ultimate end bearing resistance. Okay, the same thing as I explained, the only thing that we want to know is that what is the QF, what is the FS. So A, B, AS ni pun I have explained just now. Okay, FB is a partial safety factor for ultimate end bearing resistance. FS is a partial safety factor for ultimate shelf resistance. So actually there are many formulas, what we call it here is theoretical formula involved or derived to have this kind ultimate bearing capacity. This is deriving from the Terzaghi formula lah. Kalau you remember Terzaghi formula for straight footing macam mana, and then kalau kita ada dari kita ada square footing based on the Terzaghi formula, you have this the parameter ataupun the constant in front of the term for ultimate bearing capacity. So similar to here, it started by deriving from the Terzaghi formula, CNC plus dengan Q and gamma. So the first one here, the first term represent the soil properties, and then the second term represent of the overburden pressure, overburden stress. If you remember, kita akan ada satu lagi third term lah. Third term tu merujuk kepada unit weight of the soil. So how it is derived, that can give you the formula untuk frictional resistance QS dan juga bearing capacity and bearing capacity. Okay, let's move towards the sections. So saya pergi terus ke cohesive soil. Yang just now slide ni lebih kepada overview lah, overview kalau kata kita nak design pile in sand, kemudian kita nak design pile in clay, what are the formulas involved, kemudian kalau formula tu based on Terzaghi apa dia, kalau Meyerhof apa dia. So now we go straight accordingly to the applications in specific soil type. For example here, cohesive soil. Okay, piles in cohesive soil. So a number of factors conspire to reduce the shear strength and consequence addition around piles, such as remodeling, softening due to water in the hole or from fresh concrete or due to water seepage. It's common to assume undrained conditions exist at the time of loading, but recent studies have shown that dissipation of excess pore pressure takes place fairly quickly. By the time the pipe is fully loaded, conditions may be near to being drained. So it says here that if you remember, bila kita nak analyse any type of soil, the most important parameters are shear strength parameters, yang mana kita akan ada cohesions and then kita akan ada internal frictions angle. Kalau you have the purely cohesive soil, so the main important parameter is the cohesions. So the cohesion will tell you the strength sama ada in undrained conditions or the analysis must be done in the total stress analysis. Otherwise, you need also to consider the effect of the parameters in the drain conditions dan juga in the effective stress analysis. But this kind of the pile, it assume that the undrained condition will take place for the cohesive soil. So meaning that bila you nak analyse cohesive soil, you may see that the undrained cohesions of the clay. So the undrained cohesion of the clay that will give you the bearing capacity of the pile. Okay, this is the first method in cohesive soil using the alpha method. So sebenarnya banyak method lah kalau kita talking about method yang banyak ni dia merujuk kepada frictions lah, friction resistance. Okay, look at to this one. If you using the alpha method to calculate the skin bearing resistance, so it is based on total stress analysis. So bila talking about total stress analysis ni, you need to look at to the strength parameters lah. Nilai dia tu efektif ke ataupun total stress parameter. So they usually used to estimate the short-term load capacity of the piles embedded in the fine grain soils. So the skin frictions or additions F that develop between the soil and the pile shaft has been related to undisturbed cohesive strength of the clay. So this is as I said lah. Tadi kalau kita nampak is actually yang mana kita sebenarnya nak calculate what we want to have here, we want to calculate the, remember tadi dia punya formula QU is equal to QB plus dengan QS, yang mana QB ni adalah AB dengan apa? AB is equal to, okay, so kita ada QB, kemudian kita ada kat sini adalah S dengan Fs. So at the first one here, it is concentrate on the skin resistance bearing capacity, Fs. So the Fs ni ataupun F dia boleh ada pelbagai method. For example ya, dia cover untuk alpha method. So the F clay is equal to alpha darab dengan C. So the F clay is a unit addition of skin friction, C is a cohesive strength of undisturbed clay, and alpha is a factor that relates addition to cohesions. Okay, kemudian what we may have from here is to estimate the next one. Kalau you have the full set of the ultimate bearing capacity, it says from here the end bearing resistance, the end bearing capacity is a CuNCAB. Yang ni I just remember it is as a Q, and then dia yang ni adalah AB, the area of the base pile, plus dengan summation alpha average Cu darab dengan delta AS. Yang ni is actually as a FC. So NC, kalau kita tengok terzagi factor for intact clays is a 9. Kalau you ada fixed clays is 6.75. So ini adalah fixed number lah for NC, bearing capacity factor. Alpha is an addition factor usually taken as a 0.45 but may vary from 1 for soft clays to 0.3 for over-consolidated clays. And Cu is the undrained strength at the pile tip. So you kena tengok lah, kalau kata you ada uniform soil, so senang lah, maknanya Cu tu kita cuma ada satu Cu, nilai dia satu. For example here 80 kPa lah contoh. So there is no confusing informations lah. Kita akan ambil Cu pada base ni adalah 80 kPa. Tapi kalau kata soil you having a multiple layers, so you kena tengok lah Cu1 80, Cu2 contohnya adalah 200 kPa for example. Okay, so nak calculate untuk Cu for the first term ni ataupun end bearing capacity ni, kita nak ambil yang mana? Kita nak ambil pada first layer Cu 80 kPa ataupun kita nak ambil Cu 200 kPa at the second layer. So that is the important, yang mana you can see that kat mana the last ataupun the end, the bottom of the pile rests on which layer of the soil. So that is the tips lah untuk you identify the best undrained shear strength. Delta AS is a shaft surface area within a given layer of UD strength. Average Cu is the average undrained strength along the pile shaft. Okay, yang ni adalah variations of alpha with the undrained cohesion. Is what I said, that kalau kata there is no information only given in the graph, so you have to take it from this value lah. For example 100 kPa, so you go up, so what is the alpha, so you can take from here for example. That's how we determine the alpha kalau dia tak ada bagi maklumat lain lah. So other than that, the alpha, some suggestions, factor, for example Cu less than 25 kPa, so alpha can be taken as 1. Kalau in the range 25 to 75, so this is how we can get the alpha value. So ada some kinds of formula lah. Kalau alpha more than, kalau Cu more than 75 kPa, so alpha is a 0.5. Same goes here. So how it is relates daripada empirical equations to have this kind alpha dengan undrained cohesions. Okay, sekejap ya. Sekejap. Okay, for the second method, tadi kita dah pergi ke alpha lah. Sekarang kita pergi ke beta method. Okay, beta is proposed by Berlin 1973. So it is based on the effective strength analysis. and it is used to estimate the short-term and long-term pile load capacity in all soil types. So limitations untuk alpha method just now is only involved with the TSA dan juga short-term. Tapi menggunakan beta method ni, dua-dua boleh guna untuk long-term dan juga short-term. The excess for water pressure that develop when piles are driven in saturated clays gradually dissipates. So the unit friction resistance for the pile can be determined on the basis of the effective stress parameters of the clay in the remodeled state. Okay, selain daripada tu, apa yang kita boleh highlight is the difference formula yang mana beta method sekarang ni dia dah mengguna pakai iaitu okay, average vertical stress tangent delta AS. Okay, what is the beta S? Is the addition factor usually taken between 0.25 to 0.4. AS is the shaft surface area, average overburden stress, and then K naught is the earth pressure coefficients. So I think that when you go more details, you akan nampak lah. Actually the alpha method quite easy lah sebab dia hanya melibatkan short term stability dan juga total stress analysis parameter. And then cumanya dia ada some kinds of limitations lah. And the next one is sebenarnya yang alpha method ke beta method ni semua nak cerita macam ni, nak kira dia punya skin resistance. If you look at the term for end bearing capacity, dia benda yang sama. CUNC alpha ke beta method ke, dia tak terkesan. Yang terkesan pada skin resistance sahaja. Okay, yang ni pun the same thing is on, but showing to you the differences how it is deriving from the experimental having different normal consolidated clays dan juga over consolidated clays. This is the formula where we can have the K is the earth pressure coefficients. So 1 minus sin effective phi ataupun equal to 1 minus sin effective R square root OCR. Okay, selain daripada tu, untuk kira skin resistant, kita ada method yang ketiga iaitu lambda method. Lambda method kat sini you akan nampak perbezaan yang mana introduce the new symbol of lambda dengan kita ada Cu in the skin resistant formula. But the skin resistant formula Cu kat sini ni, we're going to take the mean undrained shear strength dengan andaian phi equal to 0. And the addition factor lambda is usually taken between 0.5 to 0.117 depending on the length of the pile. So AS is the shaft surface area, or we can say that it's a perimeter of the pile sections times dengan incremental pile length ataupun the length of the embedment. That's how we can calculate the pile shaft area. If you have the circular pile shaft area, the formula is a pi dl. And the effective, the average effective overburden pressure is counted at the center of the pile length. So yang ni kita kena be careful lah because kita akan ambil pada center of the pile length. We not take it at the ke dalam, kita akan ambil purata dia lah. Purata pada layer yang ada effect of the skin resistance. Okay, this is how it means that the mean undrained Cu dan juga mean effective stresses from the stress distributions, dan juga on the left figure here is concentrations versus dengan frictional capacity coefficients. So mostly dalam analysis we are given you the data lah, maknanya kita bagi nilai Cu ataupun the problematic sketch untuk you analyse. Okay, look at to the first example untuk undrained analysis. For example, for here, we have a pile diameter of 400 and the length is 6 meter is to be installed into a deep deposit of clay. So the clay has undrained shear strength of 180 kPa at a seed depth of 6 and average undrained shear strength of 120 kPa over the depth 0 to 6. Okay, yang ni kalau kita nampak the problem is a single layer. Assuming NC is a 9, so you look at from here, they're given you the alpha, the addition factor. So daripada 3 methods yang kita ada, dia hanya analyze menggunakan alpha method. So determine the ultimate bearing capacity of the pile. First of all, you need to calculate the end bearing capacity, CB and CAB. So I think this is easy lah sebab kita hanya direct using formula lah 180 darab dengan NC 9, area of the base footing sebabkan kita ada circular pile iaitu diameter given here is 400. So kita boleh pakai pi d square over 4. And what is the skin resistant bearing capacity? Skin resistant capacity is alpha times dengan average CU times dengan AS. So alpha is a 0.6, undrained shear strength is a 120, AS is a shaft perimeter area is a pi DL. Diameter is a 0.4, L is a 6. So kita andaikan the embedment depth length, embedment length of the pile is a 6. So the total ataupun the ultimate bearing capacity of the single pile is equal to 203.5 plus 542.6 kPa. So the last answer is a 746.1 kPa. So this is a straightforward application in the clay soil. This is the summary untuk formula menggunakan terzagi dan juga menggunakan Meyerhof. So Meyerhof ni is actually has been given in the initial slides yang overview tadi. Tapi yang ni saya terus summarikan lah. Kalau kita ada driven pulse and then we have the ball pulse, macam mana kita nak gunakan formula from the Meyerhof ataupun from the terzagi. So the same thing is that you have to understand sebenarnya kita nak cari pile tu combination from which one? Adakah pile from base and bearing sahaja ataupun from the skin resistance? So to that part here, ada juga formula empirical equations yang kita boleh ambil data daripada in situ testing lah, for example standard penetration test. So the standard penetration test is given to you some kinds of the relationship untuk you calculate the CN. I will check out balik apa nilai CN tu. I think that this is relates dengan standard penetrations number lah, value. Okay, yang ni adalah summary daripada apa yang kita nak highlight in calculations of the calculations ultimate bearing capacity in the clay ataupun in the cohesive soil. The next one is that another part is I think that the lateral earth pressure coefficients is depending kepada which method you are using. Kalau you ada alpha ni kita dah tak ada pakai nilai K dan juga kita tak pakai tangent delta. So be careful on that one. So kita akan pakai K tangent delta ni kalau dia menggunakan skin resistant for lambda method. So kita ada alpha, kita ada lambda, kita ada beta. So you kena tengok semula lah. Tadi beta untuk K dan juga tangent delta is a beta method. So supposedly this formula is modified lah accordingly. So the formula on top here is applicable for alpha method in a way to calculate the skin resistance. So yang ni kena adjust balik lah. Okay, the cohesionless soil for pile. So same thing here. Cohesionless soil pun dia akan ada few calculations untuk calculate skin resistance. So for example here, in a way to understand what is the pile in cohesionless soil, we need to know apa parameter ataupun coefficient yang terlibat. For example here, effective overburden pressure, NQ is a bearing capacity factor, KS is the coefficient of earth pressure dependent largely on the relative density, average overburden stress, and also the last is the delta angle of friction between the pile and the soil. The values of NQ may be obtained from the preceding figures in the next slides. Ini yang dimaksudkan. So actually NQ ni sama dengan yang kita ada daripada shallow foundation based on the terzagi formula. This is the coefficients, skin friction coefficients for K dan juga delta in order to calculate the skin resistance. So yang ni bergantung kepada jenis pile, the structure, and then kita ada soil type. This is what we call it the soil interaction surface antara structure tersebut dan juga pile dan juga soil. So dia akan bagi difference value for K dan delta. Same goes to the uh, internal friction angle of the sand. So dia bergantung kepada tiga benda ni lah. Phi, kemudian material of the part, and then the soil type to determine the beta skin resistance. So yang ni pun sama juga, cuma different way lah. Okay, I think that just now dekat clay tu ada silap sikit lah. Okay, yang ni yang betul untuk calculate sand. So in summary, this is what I have done and I have got from any other sources of the book. For example, kalau kata you want to calculate AP, okay, this another one is actually is AS. It's not the AP. So yang ni adalah AS. Sebab dia adalah skin perimeter surface area of the pile untuk shaft resistance is a pi dl. Kemudian kalau you ada rectangular pile is a b darab w darab dengan l. Okay, yang ni pun dia bagi the relations how we can relate untuk dapatkan end bearing for ball pile dengan SPT number. So you akan nampak lah because just now I have explained the differences between the driven parts, kemudian the ball parts. Of course the formula dia akan berbeza lah. Kalau you tengok sini, the main concept is that QB is a Q darab dengan A. Sama jugalah kalau ball pun, cuma dia punya in terms of the SPT number, untuk ball driven parts it will be different. Sama juga untuk skin friction. So you akan nampak lah the driven parts beta nilai dia berapa kalau phi 28 darjah. Beta berapa kalau phi sama dengan 33 darjah. So ini pun bergantung juga suitability of the pile to be inserted in the soil type lah. One example for sand untuk case bore pile, bore concrete. Kat sini dia ada combinations of multiple layers. For the first one kita ada granular fill, kemudian kita ada dense gravel, and lastly we have the glacial clay. So you akan nampak lah the parameters yang terlibat untuk fill, untuk dense gravel, kemudian clay. And then you have to find what is the ultimate bearing capacity for the pile untuk embankment length 8 meter dan juga embankment length 11 meter. What I want to highlight is that when you calculate for the cohesionless soil, for example here, QS is AS darab dengan FS lah kan, skin shaft, skin resistant. KS, gamma Z, tangent delta. Gamma Z ni adalah average overburden stress. So the average overburden stress, if you look at here, dia ambil pada the center of the embankment length for that particular layer. So 20 darab dengan 3 bahagi dengan 2. 20 ni adalah unit weight darab dengan Z is 3 over 2. And KS is the lateral coefficient, tangent delta. Delta ni maklumat dah dibagi. So tangent 0.75 darab dengan 30 darjah. Gravel pun sama, tapi sebabkan overburden pressure ni, kalau you tengok sekarang, kita dah berada dekat dense ataupun dense gravel in the middle layer. In order to calculate the effective overburden pressure, the average effective overburden pressure, so you can see that the changes at this part where you akan nampak pada middle layer, mana datang 60? 60 ni adalah overburden pressure from the upper soil. 20 darab dengan 3 campur dengan 21 darab 4 bahagi 2. 21 ni adalah unit weight untuk gravel, darab dengan 4 ni adalah embankment depth 7.3 bahagi 2, because they considered the skin resistance at the average length of the embankment depth. Darab dengan tangent 0.75 darab dengan 35 degree. So kalau kata untuk embankment depth 8 meter, so yang affected tu pada clay sahajalah kan. So you akan nampak lah dia punya calculation for QS and then calculation for the QB. Same thing here. untuk kat sini, CU at 7 is 120, CU at 8 is 145, CU at 11 is 220 kPa. So average CU 0.6 darab dengan 120 campur 145 bagi dengan 2. Mana datang? Datang daripada maklumat yang kat sini tau. 120 campur 145. End bearing capacity QB is a CB and C darab dengan AB. CB dah bagi, NC dah tahu, AB pun kita boleh kira. Kalau kata untuk kes kedua 11 meter, so same thing, you calculate balik. Tapi sekarang ni dia punya length tu dah berubah lah kan, dengan nilai C pun dah berbeza sebab sekarang CU at 11 meter is 220 kPa. And then you akan nampak juga the formula will be changed for end bearing capacity. So lastly, the ultimate bearing capacity for 8 meter and 11 meter is a total from the first layer, upper layer, middle layer and the last layer. So you akan nampak lah the value is 1071.8 kilonewton and 1720.4 kilonewton. Okay, we also can calculate end bearing capacity ataupun bearing capacity of the pile resting on rocks. Okay, yang ni pun salah satu cara lah sebab as we know that our geomaterial consists of the soil, kemudian ada rock, kemudian dalam soil mass tu sendiri kita ada pores and then we have the voids. So pile kita tu can be resting on the hard rock kan. So how to calculate that things? So in this slides, you will see that the formula to calculate the bearing capacity on rocks. For the first one, for example, QP. QP is a QU and V plus dengan 1. So and V ni is a tangent square 45 plus V over 2. QU is unconfined compression strength of the rock and effective V is a drain angle of the friction. And then untuk you dapatkan QU design, so dia ada kaitkan dengan QLab over 5. I think that for this part ni dia bagi the typical unconfined compressive strength of the rock lah. So nilai QU ni kita akan masuk lah untuk determine the point or the end bearing of pile on the rock. Similarly for the angle of friction, so you akan nampak different category of rocks will have a different QU, unconfined compressive strength dan juga angle of the frictions. So we can say that for example here, so the hard rock is a granite lah. Kalau you nampak sini, dia punya unconfined compressive strength is a higher compared to other type of the rock. Okay, the empirical equation by SPT and CPT from Meyerhoff. Okay, dalam this part then you will see that how Meyerhoff derives the formula when you have the SPT and SPT value to calculate the end bearing capacity and also the skin resistance. So you akan nampak there are many what we call it equations 11.37, 11.38 and then 11.39. So the important part here is the SPT and value. SPT and value kat sini they will indicate to you lah kalau kata different soil type will having different SPT and value. Kemudian selalunya dia akan ambil pada N60 which the average value of the standard penetration number near the pile point 10 depth above or 4 depth below the pile point, and this is the atmospheric pressure. And selain daripada menggunakan SPT value, kita boleh juga menggunakan cone penetration resistance value CPT. Okay, yang ni adalah what we say here. Example, if you need to calculate the bearing capacity of the pile using the field data. So yang ni adalah variations of N value from different depth and to the specific N number. For example, kalau you ada 5 feet, the N value is 8 and then you go deeper to 70 feet. So you may find that the N is 27. So it varies lah according to the depth. So apa yang you perlu buat adalah you have to estimate the the bearing capacity of the pile using the Meyerhof method. Okay, the first part A is to calculate what is the average of the N60. So the average of the N60 is a 24. Kemudian from the equations to calculate the N bearing capacity of the pile, QP is AP darab dengan QP. So QP, the formula is given as 0.4 PA and 60 L over D. So dia punya limiting conditions is must be lesser or equal AP times 4 PA darab dengan N60. So bila you masuk kat sini, you akan dapatlah the QP is 162,000 pound. So the QP is equal to 192,000 pound. And to calculate the skin resistance, this is the formula from empirical equations yang mana the K is effective as pressure coefficient, the effective sigma naught is a vertical stress at the depth under considerations, and effective delta is a soil pile frictions angle. So same thing here, the magnitude of the K varies with the depth, so it is approximately equal to the Rankine passive as pressure coefficient Kp at the top of the pile and maybe less than. So yang ni untuk kita calculate the skin frictional resistance. So bila kita combine from the QP dan juga QS, kita akan ada complete set the ultimate bearing capacity from the empirical equations. For example, kalau kita nak calculate the skin resistance from the SPT, so it shows here that the F average is a 0.02 atmospheric pressure times dengan average value of standard penetration resistance. Kalau you ada low displacement driven pulse, you will see that the coefficient in front of this here dia dah reduce kepada 0.01. Okay, kalau kata you ada CPT data, this is how you can relate from the SPT data to calculate the skin resistance. Okay, dia buat banyak graph lah untuk you determine the alpha, the effect, the coefficients of the additions factor untuk difference L over T untuk different types of pile material. Okay, soalan yang sama tadi, cuma tadi dia calculate untuk bearing and bearing capacity kan. Sekarang ni kita nak calculate skin resistance. Kita ambil equations yang dibagi pada 11.45 iaitu F average is a 0.02 PA darab dengan N60 average. Okay, you calculate berapa nilai N average, N60 average. So kita ada 15. So you substitute to the formula. So we have the QS is 122,000 pound. So QS PL FAV. FAV kita tadi kat sini. PL ni is the PL is the length. Okay, length. P, what is the P? Okay. P. Okay, P, if you check from here. Okay. Okay. Okay, the P. I need to check back the book from the book how it has this kind of the P. So the formula is given here, the average skin factor, and also the PL. L is a 50. P, why is a 4? So I think that is, oh, the area, the shaft of the area. Okay, true. The PL is the area of the shaft resistance. So remember just now I said that if you have the circular pile, so the area is a pi d L. So kalau kata you ada rectangular, so the formula is will be difference lah. B darab dengan H darab dengan embedment depth of the pile. Okay, true. PL is the shear resistant area, the perimeter shaft. Okay, finally the QP is what we have from here. Kemudian kita nak dapatkan the ultimate bearing capacity of the pile. So you jumlahkan antara QP dan juga QS. And lastly, if you want to check the the allowable bearing capacity of the soil, so we can have the QP plus QS over FOS. Kalau kata FOS you antara 3 dengan 2, so kita akan pakai nilai FOS yang paling kecil lah. So yang ni yang tadi dia kira cuma saya dah shortkan lah, saya tak tunjuk lah. Maknanya saya tak tunjuk QS tu tadi berapa, QP berapa, cuma saya summary-kan dekat sini. Kalau you nak dapat allowable bearing capacity of the pile in order to check the safety ataupun against failure of the pile, so kita check daripada allowable load. So this allowable formula is equal to Q ultimate bahagi dengan factor of safety. So from the example just now, end bearing is 192 KIP and then QS is 120 KIP, and the last half method for Q allowable is equal to 104. Okay, yang ni adalah summary untuk apa yang kita dah sembang tadi daripada end bearing, kemudian skin resistant dalam clay, dalam cohesionless soil untuk rock. So kalau kata in different way dalam bentuk table, but the same meaning is that this is what you can have. Yang ni pun samalah. Ini saya biarkan untuk awak do your own revisions. Any questions before we end our class tonight? Okay, last before we close our class sessions tonight, I like to have every one of you involvement just to make sure that you are aware what we are saying here, what we are learning from tonight class. Please. Okay, sekejap. Section. Okay, saya nak dapatkan feedback from every one of you. What do you understand about our class tonight? So, please scan this QR code and then give me your points. What do you get from this online class. So you can scan the QR code and enter the class code 55641 and give me what is your thoughts.
Sorry doktor.
Yes?
Nak scan QR code dekat mana doktor?
Oh, sekejap Tak nampak Sekejap. Okay. Mana tak? Ini tak? Screen. Okay, yang ni you nampak tak slide saya? Can you see my slide here?
Nampak?
And then can you see here this class code bar?
Tak ada.
Okay, never mind. If you go to the class point URL .apps, kemudian you masuk dia punya code 55641. Okay, I think that I know what's wrong. Okay, you need to go to the class point apps and then scan the QR code or enter the class point as a. Okay, what are the things that I can do here is okay, never mind. I think that tonight I will try how to use these apps just to get your feedback on these topics. So actually, in summary, what I can explain is that for the first beginning of the class, I just shared to you the pile classifications from the material type and then from the effect of the pile installations, for example, and then the pile functions. If you have the end bearing and then if you have the skin resistance and if you have a combines, depending to the applications on the purpose of using the pile. Kalau kata you nak pakai pile untuk kawasan berombak, kawasan lautan, kemudian pile tu pula perlu resist any forces ataupun moment, so you need to consider a few factors. And then we go to the theoretical part from the terzagi. Sebenarnya ada mayhaf dan juga terzagi lah. Cuma saya dah ringkaskan, I shot the slide, jump to the application in specifically for cohesive and then for cohesionless sort. That's why when you say, when you saw just now, I ada summarikan kalau terzagi punya formula macam mana, mayhaf punya formula macam mana. That's I didn't orang kata apa, my ideal way to show you and to explain to you the importance of the applications untuk different soil type. Kemudian kalau kita tengok balik macam mana the deriving formula untuk bearing capacity of the part consists of the end bearing, kemudian skin resistance. So we can see that there are many methods available to calculate the skin resistance in clay dan juga untuk sand. But I try to, bila you nak jawab soalan, you have to check lah ataupun you kena tengok parameter tu bagi simbol apa, lambda ke, beta ke, alpha. Ataupun they mention to you is that you are needed to find the skin resistance using this method. So bacalah soalan kan untuk you tahu kaedah mana untuk kita calculate the skin resistance. Kemudian you kena tengok jugalah the derivations of the formula setiap parameter ni dia merujuk kepada apa benda. Kemudian kalau dia kata average overburden stress to at which particular embedment depth. Similarly, kalau you ada end bearing capacity, kita nak ambil CU dekat mana. Kemudian kalau you ada skin resistant in clay, so how do you take the value for C? And if you are given the unconfined compressive strength, QU, tapi dalam formula kita nak pakai CU, so macam mana you nak tukar daripada unconfined compressive strength kepada undrained coefficient. So that's another way lah untuk you play around with the number and also the formula. Dan selain daripada tu, untuk kelas malam ni juga you tengok how it is applied untuk pile capacity resting on rock. Dia ada pelbagai jenis lah, sebab kalau kita tengok rock ni, rock can be classified into three main parent rock. Kita ada igneous rock, kita ada sedimentary rock, kita ada metamorphic rock. So setiap rock tu akan, setiap batuan tu dia akan bagi you different internal friction angle dan juga unconfined compressive strength. Yang mana dua nilai ni kalau you menggunakan empirical equations, dia akan adalah the formula yang kita boleh pakai. They drive you to the which formula suitable to calculate. And the last part is saying on the empirical equations to calculate the ultimate bearing capacity, especially on the skin resistance. Maknanya kalau kata untuk skin resistant, kalau kita guna empirical data daripada SPT ataupun CPT, apa formula yang sesuai. And then kalau you tengok balik untuk end bearing capacity, if you have from the SPT data pun dia berbeza sedikit lah, tapi dia tak lari banyak berbanding skin resistance. So that's I can summary, and unlucky I couldn't have your feedback from this tonight class. Apa you understand? For your information also, we have another project related to this topic. So saya akan bagi projek tersebut pada hujung minggu ni kalau sempat lah. Kemudian projek tu you perlu submit pada minggu terakhir. So just be ready lah untuk buat projek. I think this is a group project lah untuk you submit dan buat. So kita akan guna group yang sama untuk hari tu. Ada soalan tak sebelum kita habis kelas untuk malam ni?
Doktor, slide ni ada tak doktor?
Slide ni nanti saya upload dalam YouFuture ya. Okay, satu lagi saya nak maklumkan, kita akan ada guest lecture untuk subtopik pilot testing. Okay, saya share satu lagi picture in WhatsApp group. Kat sini adalah tentatively topik yang berubah mengikut tarikh lah. For example, for this week dan juga next week Tuesday saya akan take over the class. Kemudian pada minggu berikutnya dalam 18 hari bulan 1 kita akan ada guest lecture piling on site testing. So actually 18 hari bulan 1 is a public holiday. If I'm not mistaken, it's a typo sum. So I think that this is a fixed date approved by faculty. So we're going to proceed this guest lecture online at the same time 8 p.m. So I hope that every one of you can join at 8 p.m. sharp. And the last week pada 24 hari bulan Januari itu saya akan take over balik untuk cover parquet dan juga structural designs. Okay, and I think that revision week tu is preparing for you to have group discussion ke apa benda lah kan untuk you prepare for the final exams. So if I'm not mistaken also untuk group project yang saya nak bagi ni dia tak perlu present. So I think that it's only you submit dalam group kemudian habislah, tak perlu present. Sebab nampak kita macam agak terikat dengan masa lah sebabkan hari tu kita ada cuti emergency kan. Kemudian I think that I leave it for you revision week tu dengan kita tak ganti apa-apa topik lah. It's lucky for you lah sebab kalau dia melibatkan lecture, your punya revision week tu akan jadi pendek lah. Sebab kat situ minggu tu adalah minggu Chinese New Year holiday. revision week tu. So just remind and aware every one of you yang working students ni untuk you lebih prepared lah, bersedia. And also I just since that kalau kita tengok lah kan daripada our slides ni, skin resistance tu punya banyak method kan. So saya tak naklah kata okay fokus pada alpha, no. You kena tahu juga alpha macam mana nak kira. Kalau kata pakai kaedah beta, then kalau pakai kaedah lambda, so you can see the differences antara parameter satu method dengan method yang lain. Tapi dari segi convenient, is more convenient using the alphabet method lah, because less complexity. It's only use a total stress analysis ataupun short term stability. And another way atau in the short meaning, kita hanya menggunakan undrained shear strength parameter lah. So that is benefit menggunakan alpha method. And then kalau you tengok antara terzagi dengan Meyerhof, dia akan ada possibility lah untuk ditanya menggunakan kaedah terzagi ke atau menggunakan kaedah Meyerhof. Okay, untuk this slide I will give later upload in the future, so you boleh ambil daripada situ. Dan saya akan buat finalize note lah sebab tadi baru saya perasan ada some typo untuk certain things. So I think that lepas tu lah you boleh download sebelum mula minggu depan. Okay. I think that's end for class tonight. And everyone are tired, so Assalamualaikum and goodbye.
Waalaikumsalam. Terima kasih doktor.
Welcome.
Thank you, Doctor.
Terima kasih, Doktor.
Thank you, Doctor.
Terima kasih, Doktor.
Terima kasih doktor.